So good day. So here is the video discussion for our topic secant method. So ang content lang ito is all about secant method. So by definition, it is an improvement of the regular falsi method. Okay, improvement siya ng regular falsi and also applicable to polynomial and transcendental equation. The second method constructs an approximating straight line connecting the two functions of the initial values similar to that of the regular falsi method to estimate a root value. So the technique start off by assuming two initial values are labeled as 0, 1 and 0, x0 and x1 along with their respective functions. So note the two initial functions should only follow the condition. Ang fxo natin dapat hindi equal kay fx1. So kahit etong natin, ang second method, wala siyang bracket method. Hindi siya bracketing techniques. So dapat hindi lang parehas yung fxo natin and fx1. So, for two different values of x, meaning both function, pwede silang both na positive, pwedeng both na negative, or opposite signs. Yung parang ginagawa natin dati na may negative and then merong positive. Other than that, there are no other conditions are needed. So, ito yung graphical definition natin ng second method. So, kung ito yung function, so, like we get xo and x1. So, ito lang yun. Itong line na to. So, second line. So, iterative formula natin parehas sa regular falsi. Walang pinagkaiba. Now, after solving for a new root estimate, x2, substitute x2 to the f of x to obtain fx2. And to continue the process, disregard xo and substitute the previous x1 to xo. Then substitute the computed x2 to x1. So, ibig sabihin, from xo, di ba? Tapos may x1 ka. So, ito yung x2 natin. Tama. So, kung ito yung iteration 1, so, ang iteration 2 natin, so, si x1 magiging xo. So, ito yung magiging xo. Si x2 magiging x1. And then, makukuha natin yung new value of, or the new root estimate value of x2. So, ganun lang. So, pag 3, si xo mawawala. Ito, siya yung magiging new xo. Si x2, lilipat, magiging x1, and then new value si x2. So, maalis si xo. So, obtain a root from the given function using second method. So, pare-parehas yung binibigay kong example. Itong function na to. So, ER pa rin, ganon, 0.01%, 5 decimal places. So, assume any two initial integer values. Since ang ginagamit na natin dati is 4 and 5, yun na yung gagamitin ko ulit. And then, so as you can see, magkaiba yung value ni fxo and fx1. Yun lang naman yung rule natin. Dapat fxo is not equal kay fx1. Yun lang. Kahit pa parehas na parehas na negative yan, okay lang. Parehas na positive, okay lang. Or in this case, negative, positive, okay lang din. So, kukunin natin si x2. Same formula from regular falsi. So, ang x2 natin is 4.23077. And then sa substitute natin to the function x cubed minus 4x squared plus x minus 10. Ang fx natin is negative 1.63858. So, yun nga, substitute x1 to x0, x2 to x1. And then, ang xo natin ngayon is 5, x1 natin is 4.23077 with values of fxo and fx1 na solved na. So, kukunin natin si x2, so x1 minus the quantity fx1 times x1 minus xo all over fx1 minus fxo. X2 natin is 4.28902 straight. So, substitute natin to the function x cubed minus 4x squared plus x minus 10. So, 4.28902 cubed minus 4 times the quantity 4.28902 squared plus 4.28902 minus 10. So, fx2 natin is 0.39426. Ito yan. So, substitute x1 to xo and then x2 to x1. Pero wag natin kakalimutan si relative error with the formula absolute value of x2 present minus x2 previous all over x2 present times 100%. So, makuha natin ni ER for the second iteration is 1.35812%. Third iteration, new values in xo and x1. x2, makukuha natin is 4.3748 from the formula. So, substitute natin to this. So, substitute lang natin per x. So, fx2 natin is 0.01258. For the third iteration, substitute x1 to xo. So, x1 to xo and then x2 to x1. ER, present minus previous over present times 100% with absolute value 0.42856%. So, the process is repeating hanggang mag-terminate. So, ang x2 natin dito is 4.30691. And then substitute. So, 4.30691 cubed minus 4 times the quantity 4.30691 squared plus 4.30691 minus 10. So, x2 natin is negative 0.00007. Then, ganon. Paulit-ulit lang to. Substitute x1 to xo and then x2 to x1. With a relative error of 0.01323%. So, hindi pa siya less than or equal to 0.01%. Fifth iteration, ang xo natin is 4.3748. xo yun. x1 is 4.30691. So, from the formula, x2 is equal to x1 minus fx1 times x1 minus xo all over fx1 minus fxo. x2 natin is 4.30691. And then substitute natin to x cubed minus 4x squared plus x minus 10. fx2 natin is negative 0.00007. Then substitute x1 to xo and then x2 to x1. So, yung x, as you can see actually, yung x2 natin for iteration para sa x2 natin for fifth iteration. So, kung naging ganon, okay lang yan. Meaning, ang ER natin is 0%. Kasi parehas yung x2 natin, previous and present over Ito, syempre, 0 sa taas over, kung ano yung value niya, times 100, ER. Ibig sabihin, noon is, determinate na natin yung process. So, root natin is 4.30691. So, ayan yan. So, ang value na nakuha natin is negative 0.00007. So, almost 0 na siya. And this is the tabulation. So, ito na yung final answer ng second method. So, madali lang siya. Kaya pinagsabay ko yung regular falsi at false second method kasi halos magkapares na lang yung way ng pag-solve niya ng x2. Pagkakaiba lang is yung values. So, ang nangyari kasi dito, si xo nawala, tama. Si x1 mo naging xo. Si x2 mo naging x1. Siguro lang yun. x1 naging xo, x2 naging x1. Tapos makukuha yung x2. So, ganoon. x1 naging xo, x2 naging x1. x1, x. Siyempre, ganun din yun sa f of x. F of x1 mo, naging f of x2. Kasi, mag-change yan kasi, uh, kumbaga gagayahin lang niya kung paano nag-change yung x1 at x1. Okay, so that's it's our part 1. For second method, so watch me rin yung part 2. Goodbye.